So today we're going to talk about quadratic graph characteristics. Our quadratic equation can be represented in various forms. We have our factored form, where we have our two factors that are multiplied together. We learned about factoring in the last unit. We have our standard form, ax squared plus bx plus c, and it looks exactly like our quadratic formula, what we would use to plug into there. And then we have our transformational or vertex form that we did in unit 1. So there's our vertical stretch or shrink. This is how we move our graph left or right. So our horizontal shifts and our vertical shifts, we move it up or down. Quadratic graphs have all the same characteristics we've been talking about, but we're going to look at two new ones that they've always had. We just didn't discuss them in the beginning because not all graphs have them. They have an axis of symmetry and a vertex. So axis of symmetry is the x value where the graph is symmetrical about. So it's basically, if I were to draw a vertical line, where does it split my graph in half? If I fold it along that vertical line, where is it symmetrical or a mirror image of each other? And it is going to be our h value from our transformational form. So we're going to say x equals h. We can think about our transformations and what direction it goes. For the vertex, the point at which the graph changes direction, so it changes from an increase to a decrease, it's our maximum or minimum point. And it's going to be our hk from transformational or vertex form. If a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens downward. So if it's in transformational form, if that is positive, it will open upward. If it's negative, it opens down. In standard form, we look at the one, whatever's in front of x squared. So if it is positive in front of x squared, it opens up. If it's negative in front of x squared, it opens down. In factored form, we usually look on the outside of the parentheses as long as our x's are positive inside. If there's a negative outside, then it would open down. If it's positive, it opens up. This is just a quick example, general example. So if we have a quadratic, there's our axis of symmetry, and we'll do dotted lines to kind of show it. And then there's our vertex, the lowest or highest point. We're going to state the transformation for number 1, and then we're going to figure out the graph characteristics and graph it as well. So when we look at number 1, this 2 on the outside is going to be a vertical stretch by a factor of 2. The plus 3 on the inside is going to go left 3. And then minus 2 on the outside is down 2. We can get some of the information to fill in here from the equation itself, but I always kind of like to look at the graph first. When I look at my graph, I can use my transformations to help me graph. So I know most of the time I go through 0, 0. However, I say I'm going to move left 3 and down 2. Most of the time, if I don't have a vertical stretch or shrink, from the vertex, I go up 1, right 1, up 1, left 1. However, because I have a vertical stretch of 2, I'm going to go over 1 and then up 2 instead on each side because it's symmetrical. And again, most of the time with quadratics, I go over 2 and up 4, but this time I'm going to go over 2 and up 8 from the vertex. One more, right there you go. Whoa, that one got a little wiggly there. This is the nice thing about Desmos, is that it gives you a really pretty looking graph where if you hand draw it, sometimes it gets a little wiggly.